In this video, we'll be sketching the graph of a rational function. Our first step is to determine the vertical asymptotes. We let the denominator equal 0 and solve. So x equals 3 is our vertical asymptote. We need to draw a line to indicate that our graph cannot cross that vertical line. If it does, then x is equal to 3 and we have division by 0, which is undefined. Next, we need to determine the non-vertical asymptotes. And we do that by comparing the degree of the numerator and the degree of the denominator. You can see that the degree of the numerator is larger than the degree of the denominator. So that means we're going to have an oblique asymptote, and we find the equation by dividing. This is sometimes called a slant asymptote. And we're going to ignore the remainder. Since my denominator is a first degree polynomial, I'm going to use synthetic division. So I need to put a positive 3 in the little box. And then I have the x term is missing, so I need 2, 0, and 5 for my coefficients. Bring down my first term, so 2 multiply 6, add, multiply, add, and then ignore this remainder. So if I put my variables back in, it looks like y equals 2 times, let's see, this was second degree, so this will be first degree. 2x plus 6 is my oblique asymptote. Now this is just a line with a y-intercept of 6. So 1, 2, 3, 4, 5, 6. And slope of 2. So up 2 and right 1, or down 2 and left 1. So it looks like my oblique asymptote is going to come down like this. Next, I need to find y-intercepts, and you do that by letting x equal 0. So y-intercept, let x equal 0. So we have y equals 2 times 0 squared plus 5 divided by 0 minus 3. So y equals 5 over negative 3 is my y-intercept. This is negative 1 2/3. So negative 1 2/3 is where my graph is going to cut the y-axis. I can find x-intercepts. Do that down here. X-intercepts, let y equal 0. So we have 0 equals 2x squared plus 5 over x minus 3. Multiply both sides by x minus 3 to get rid of that denominator. These will cancel. 0 times anything is still 0. Equals 2x squared plus 5. If we subtract 5 from both sides, I have negative 5 equals 2x squared. Divide both sides by 2, and x squared equals a negative 5 halves. Now if I square root both sides, you can see that we're not going to have a real number. X is equal to the square root of 5 halves I, and plus or minus. Now since our graph is on our real coordinate plane, that means that since my solutions to this equation are imaginary, my graph is not going to cross the x-axis. So there are no x-intercepts. So I have enough to determine, at least in this section of the graph, what's going on. I can't, from this point that's on my curve, I can't go up either direction. So I'm going to have to hug the asymptote. Hug the asymptote, go through my y-intercept, and then come down here to this asymptote. Now to decide what's going on the right side of my vertical asymptote, I can put x equal 4 in my equation. If x equals 4, I get y equals 2 times 4 squared plus 5 over 4 minus 3. So y is equal to 16 times 2 is 32 plus 5 is 37 over 1. So y equals 37. So the point 437 is going to be on my graph. Now you can see that that's going to be way up there off my paper, but I'm going to have something that's going to come in and then go off graph. So if this was 37 up here, this point when x is 4, I know that my graph is going to have to make like a check mark up there.